So now I want to talk about, like we talked about how MongoDB is faster than relational databases, and it really, I think NoSQL has won as far as the way things are going. Normalization was done to save on disk space. Disk space is cheap. What's expensive these days? CPUs. That's kind of where the relational database falls down, is it requires a lot of computation to be able to do these joins. Mongo does not, and it basically is able to store that data as it comes in and pull it out. It's super fast. The central nervous system of Kafka is very powerful. And so I wanted to show how these two technologies work together. MongoDB and Confluent really work well together. They're both open source technologies, so you actually have access to the source code if you want to go that deep. And you can actually use open source versions, community versions of Mongo and Kafka. We have a lot of customers that are doing POCs that didn't cost a dime to get started. You can run on premises, you can run hybrid, you can run in the cloud, and you can run on all three of the major cloud providers. And both of them have technologies like we're talking about cluster linking that allows you to run cross-cloud. So you can actually have a server in Mongo running in GCP and AWS, for example, at the same time, right? So that replication is occurring in real time. It's part of the same cluster. You can even fail over across clouds. Same thing with Confluent, with cluster linking, you have that capability. So that's really cool. We also have a source and a sync connector that allows anything that's sourced in Mongo to go straight into Confluent, vice versa. Anything that's in Confluent can be synchronized to MongoDB. So the change streams is something that MongoDB has. It's basically looking for any data that is updated in the database, and it's kind of, you can take that data and listen to the change streams that are going through Mongo. Everything's been written or updated, and you can take real-time event notifications out of Mongo through the change stream API. So you can do things like the MongoDB Atlas triggers. That's great. You can notify downstream systems, or like they could actually open a change stream into MongoDB, or you could send it to Kafka through the connector. And so the connector, we have a sync connector, topics coming in from Kafka, being sourced from Kafka and then pushed into MongoDB. And so anything that's written to a Kafka topic in real time is synchronized to MongoDB. Vice versa, anything that happens, any type of change using change streams, we have the MongoDB connector that puts it into a topic in Kafka. So basically the source can be MongoDB, Kafka's aware of it. Once Kafka's aware of it, everyone's aware of it. It's basically a nice way to get data through there. So here's an example that I've seen in a lot of financial institutions. Lots of different banks. Toyota Financial Services is one that's probably referenceable, but there are a lot of private banks that are doing this transformation. They have like a banking system where they're doing check clearing and payment processing to another banking system, talking to an IBM mainframe or an AS400. And they've got DB2 on there, and they're using things like the DB2I CDC agent that's actually looking at the logs on the, for DB2. And it's using the IBM CDC Kafka agent to put that data into the Confluent cloud. Once it's in the cloud, we can use the MongoDB connector to push that data to MongoDB Atlas. You can run custom reports, analytics, all that good stuff. What does that do? Well, it offloaded those reads, right, to MongoDB Atlas from the mainframe. And typically reads are about 60 to 70% of the MIPS on a mainframe. So you've just saved a ton of money by doing this, right? And you've enabled microservices and other applications to read from MongoDB Atlas versus the mainframe. So that's like a huge step forward. And it's very easy to do. Toyota Financial Services use NiFi, but you also have Click. So NiFi and Click, those, we have connectors for those. They go right into Kafka, put that data into Mongo, big powerful thing. We also have Salesforce connectors, so we can update Salesforce in real time. So anything that happens on DB2, a payment comes in, I can apply that payment to customer data in Salesforce in real time. And that was very important to TFS. We'll actually kind of get to that in a second. Confluent Kafka basically puts data in motion across the enterprise, and then it can make decisions as events occur. So we have this thing called stream processing. So as a thing comes into a topic, I can look for a value that's over a certain amount. I could look at banking transactions that are over a certain dollar amount and put that into a new topic that checks for fraud, right? And I can go to machine learning and things like that. So these things actually happen in real time. Being able to see what that data is, to filter that data, to join across topics. I can join data from Oracle and DB2 together inside Kafka, create a new JSON document and push that to Mongo, right? So it's an easy way to get a customer 360. That's another really good use case that this powerful technology does. Mongo is great because you can append information to that customer document. MetLife is a great customer 360 use case. I was a customer of MetLife, and I constantly would call in and I wanted dental insurance. They go, oh, you called the auto number, and that was a pain. But I remember when they actually implemented this, I called in, I don't know if I'm at the right department. They go, yeah, we've got your dental insurance information, no problem. Because all that was stored in a document. So they didn't have to go across multiple systems. Customer 360s are a great use case. We can take that data, give it to Mongo. Mongo can put it in a document structure and surface it up. And we're seeing a lot of that being used across the board. So MongoDB, we talked about Kafka, it's the perfect place to do those real-time processing, decision, and joining of streams of data in real time, put that into Mongo. What does Mongo do? Well, it's the perfect landing platform for data at rest. So once something gets in there, you've got the whole history of generated events. I can tell you what's going through this one particular customer right now, but if you want to see all the policies that that customer has at MetLife, that's Mongo, right? Because he may have had a life insurance policy that he did 2 years ago. That's not real-time data. That needs to be data at rest. That's going to be here in MongoDB. So between these two technologies, though, this is the key point. You literally capture the entire data lifecycle of an event. So everything that happened, everything you want to know about that customer, anything you want to know about an object or a person or a time or a place, these two technologies cover the whole gambit. You don't need anything else. I mean, long term, you may need something for like a data warehouse query if you're doing like analytics across petabytes of data, something like Snowflake or Google BigQuery or something of that nature. There is a use for that as well. But Mongo is really good for transactional processing and what you care about right now. All the data that's there and what the current state is. That is very powerful in Mongo.